Hello guys, welcome back to Speedlabs, and in this particular video we will talk about the basic, that is the basic of physics, that is basically all about calculus. Okay, so calculus is, what is calculus? So calculus is nothing, it is just basically a branch of mathematics in which we will talk about the derivatives and integrals of function. Okay, there is a function like y equal to f of x, it is the function. So we will talk about the derivative of that function and integral of function. Okay, how we will do it? We will do it by the methods which are basically based on the summation of infinitely small differences. Okay, so we are going deep into the function and we will divide that function in a very small infinitely particles. Okay, oh sorry, not particles, basically we divide it. Okay, and we will talk about the integration and differentiation mainly. Okay, so what is actually the calculus? It is nothing, it is the branch of mathematics in which we will talk about the derivatives dy by dx and integral means integration f of x dx. We will talk about it. Okay, and we will try to understand what is actually it is. Okay, so are you ready? Okay, so let us move further. Okay, so as you can see that calculus, there are mainly two types of calculus, that is differential calculus, that is if y is equal to f of x, we find the dy by dx. This dy by dx is basically comes in differential calculus. And what is the actual meaning of this? This is nothing, this is basically the rate of change of y with respect to x. Okay, when I have this y2 minus y1 upon this x2 minus x1, and let's say their difference is very small. If this x2 minus x1 is very small, you can say it is infinitely small, then this will convert into dy and this will convert into dx. Dy and dx are very small, in very small, like y distances and x distances. Okay, so this is basically differential calculus, and we will talk about the integral calculus also. Okay, so integral calculus is nothing, it is this the integration of this f of x dx. Okay, this is basically mainly based on integration. Okay, so this is all about we will talk about. As you can see here, I have this y-axis, here I have this x-axis, and this is basically the red, basically this is a curve. Okay, and this is a function f of x, and you can see y is equal to f of x. Here x is an independent variable and y is a dependent variable. If you put the value of x, okay, this is independently, you get the different values of y. Okay, so if I have this function and if we draw a tangent, at that particular point, then the inclination with this x-axis theta will give me the slope. Okay, so this is basically the method which is based on this slope. Okay, so this is all about. If you find the inclination of between these two very small distances, what you will do, you are going to make a tangent, and okay, this tangent will make something angle with this, and this angle is known as slope. Okay, or you can say this is basically denoted by small m. Okay, small m is basically the slope. Okay, now in basically integral calculus, I have a function like this. Let's say this red is basically a function. Okay, this is the function. Okay, if you need to find out the area of this particular function, the area under this function, okay, how can I do? It is very difficult for me because it is not a straight line, it is very curved line. So how we will do? We will divide this particular thing in a small, very small rectangles, and these small rectangles on adding and calculating the area of very small rectangle and adding these rectangles, what we will get the whole area of this particular thing. Okay, how we can do it? We can do it by putting the limits. Here this a is known as lower limit and there is b is known as upper limit, and this is basically f of x dx. Okay, so this is all about the integration. Okay, so this is mainly based on integral calculus. Here we need to find out, here the basic meaning of this, we are finding the rate of change of something quantity with respect to other quantity. Here we will find out the area of curved surfaces. So for finding the areas, what we will do, we will do the integration. Okay, for finding the rate of change, what we will do, we will do this slope method. Okay, so this is all about this. Okay, so now let us move further. Okay, so let us talk about the differentiation first. Okay, so if I have a function, let's say y equal to f of x, here x is a independent variable as I have told you, and y is a dependent variable. Okay, so what is the value, what is the meaning of this dy by dx? Dy by dx basically means the slope. It will give up the slope of the tangent at any particular point on the curve. So what is the physical meaning of this? The dy by dx or dy by dt, what is the physical meaning of this? If I have, let's say, dy by dt, here basically what it means this y is changing with respect to time. Okay, you are just putting the value of time, and with respect to time, that how much y is changing we will get from this dy by dt. Okay, so if I have dy by dx, it is the physical meaning of this, that the rate of change of y with respect to x. Okay, this is all about the differential calculus. Okay, so there are basically some differential coefficient of some standard function. Okay, so if you will talk about the differentiation, let's say if you talk about the differentiation, this dy by dx of, let's say, x raised to power n. So what is the standard result, standard differentiation, you can say? Here this n comes like this below this side n, and this is x, and if you will subtract this n by -1, so this is basically the standard result you will get from this. Similarly, there is a differentiation. What is the differential coefficient of this e to the power x? It will be e to the power x. So there are various formulas you need to remember. Like similarly, if you want to calculate the differentiation, the rate of change of sin x with respect to x, the sin x curve. Okay, so what it will come? It will come like cos x. So there are basically different formulas you need to remember, like differentiation of what is ax, it is ax log ea. What is the differentiation of log x? That is 1 by x. Differentiation log base ax, what is 1 by x log ae. Okay, differentiation of sin x, that is cos x, I have told you. Differentiation of cos x is basically minus sin x. Differentiation of tan x is sec square x. Differentiation of cot x is minus cos x square x. Differentiation of sec x is sec x tan x. Differentiation of cos x is minus cos x cot x. And differentiation of something constant. Okay, if you have, let's say, constant 5. Okay, this 5 is a constant, so it will change with respect to x? No, it will not change. So what will be the change? It will be 0. Okay, so the differentiation of constant quantities is 0 because it will not change. It is the constant, is the universal constant. Okay, so basically this is all about the integration. Okay, so there are some rules for finding differential, or you can say derivatives of composite function. Okay, like if you have, let's say, differentiation, let's say of, you want to do the differentiation of, let's say, 5 sin x. Here 5 is a constant. Okay, it is not changing, so you will just make it out from this differentiation. So it will come 5, and what will be dy by dx of this sin x, that I have told you, that is cos x. So what is your answer? That your answer is 5 cos x. So this is how you can do. If you have, let's say, two functions, okay, like you have, let's say, this is your first function u, this is your first function, let's say, second function b, and this is equal to y, and if you need to find out the derivative with respect to x, how you will do? You will just differentiate du by dx, okay, plus that is dv by dx. So this is how you can do. And if, let's say, if there is a minus, you just put there the same minus sign. So this is all about you can do. But you have, let's say, a function, let's say, which is a product, okay, which is comes in product. Let's say if there is a function, let's say y is equal to, let's say, this is first function sin x and the second function is cos x. Okay, now if you need to find out the differentiation of these two function, how can you do it? You will do it by a, let's say, one formula. Let's say this is considered to as first function, this is considered to be a second function. So differentiation of first function and this second function, how will do it? You will do it that first function you will just keep here, and just you will differentiate the second function with respect to x. Similarly, you will keep this second function here, and you will differentiate this first function as like this. So this is basically the formula you need to remember. This is known as the product rule. Okay, this is basically known as the product rule, as you can see here. Similarly, there is a division rule. Like if you have two function u and v, these are in divide. Okay, so what you will do? You will just put the second function here, differentiate first function, minus put here first function. Okay, this is your first function, this is your second function. Okay, put this first function here, and you will differentiate this second function here. Okay, and divide this second function square. So this is all about the differential calculus. Okay, so this is basically a chain rule. Here is a chain rule also. If I have, let's say, a function under a function, okay, so if I have, let's say, this is sine, and in place of x, let's say, I have this x square. So what we will do? We will differentiate first sin x. So what will be the differentiation of sin x? That is cos x square. Now this x square is under this, basically x is basically a whole theta na? So we will differentiate this x square separately. Okay, so this will be our x square. So what is the result we are getting? This is cos square, and what is the differentiation of this? This is 2x. So this is our desired differentiation dy by dx. Okay, so this is how we can do the differentiation as you can see on whiteboard. Okay, so this is all about. Now let us do some numericals. Okay, if y is equal to x square, if you have y and this is equal to, let's say, x square, so you have to find out dy by that is very simple, dy by dx. Okay, as I have told you, you will just make this 2 come out of here, let's say 2, and you will just put hex and you will subtract it by minus. So what you will get 2x1, that is 2x. So differentiation of this x square, what is you are getting, that is 2x. Okay, this is basically the 2x. Okay, now the derivatives of, let's say, x square sin x. Okay, so you will differentiate like this. Let just do it like this, x square plus this is your sin x. Okay, now you need to derive it. Okay, so what will be dy by dx? Okay, so what is the value of this derivative? That is 2x. And what is the derivative of cos x? That is sin x, that is cos x. So this is the answer you are getting. Okay, now let us do one good question. Okay, like this, I have a question. Let's say a particle moves along a straight line such that its displacement at any particular time is given. Okay, so displacement we have given, that is t cube minus 6t square plus 3t plus 4. This is basically the displacement. This displacement is basically a function of time we have given. So by putting the value of different time interval, we are getting the different displacement. So this is basically a function. Okay, here this t is an independent variable, but this s dependent on this particular t. So this is the dependent variable. Okay, so we need to find out what we have to find out the velocity when the acceleration is 0. Okay, so when the acceleration is 0, we will have to tell what will be the velocity, okay, at that particular time. Okay, so what is acceleration? It is the rate of change of velocity. Okay, so here I have given the displacement. Okay, so as I have told you, the rate of change of time, the rate of change of displacement with respect to time, the rate of change of displacement with respect to time will give me the velocity. Okay, so this velocity will be like 3t square, okay, minus this 12t, and this is basically 3, and the differentiation of this constant will be 0. Okay, now the differentiation of this velocity, the rate of change of velocity with respect to time, will give me the acceleration. Okay, so what will be that differentiation? Okay, we will do it separately. Okay, now we will do it here. Okay, we will do it here. Okay, now we will differentiate this velocity with respect to time. So dv by dt, what is the dv by dt? Dv by dt is basically acceleration, and what will be? It will be 60. It will be 60 plus that you are, sorry, that is minus, that is here minus, and what is the differentiation of this 20? That will be 12. Okay, so this is your acceleration. Oh, now the question is saying the acceleration is 0 at particular point. So let me find out the time. Okay, so this acceleration will be 0. So what will be the time? Time is equal to 12 upon 6. So particular, I can say at 2 second the acceleration is 0. So what will be the velocity at that particular time? So velocity is basically what? It is given 3t square minus 12t plus 3. So putting the value of t, basically 2 in this equation, this will give the velocity at particular timing. Okay, so that time will be 2. Okay, so now putting this value, what will we get? We will get 2 square minus 12 into 2 plus 3. So what will be this? This will be 4 into 3, that will be 12. Okay, minus what is 12 into 2? That is 24. That will be 3. So this will minus 12, and this basically this will be, if I will solve this, what do I get? We will get minus 12 plus 3, that will be equal to minus 9 meter per second. So what you can say, as you can say, at t equal to 2 seconds, the velocity of the particle is minus 9 meter per second. This minus sign is showing that it will go into negative side. Okay, so this is all about the differential calculus. Okay, so this is all about the differential calculus. It is nothing, it is just a branch of physics, okay, mathematics, in which we will mainly talk about the derivatives or integrals of a function. Okay, so I hope you love the video. Thank you so much for watching. Have a nice day.